All right, so I think this is recording. Let's take a look at solving these three equations. They are rational equations. We know this because we see ratios, we see variables in the denominator, and whenever we see variables in the denominator, we do have to be concerned about division by zero. We can't allow certain values of x to occur that cause that to happen. Let's jump in and take a look at number 4. On the left-hand side, we have a single term, um, and that term has an x minus 2 in the denominator. And here, this on the right-hand side, this first term has an x minus 2, so those are common denominators. But here with this minus 2, we look at that as 2 over 1, and we see that this does not have the same denominator as the other two terms. So we need to have that term, all these terms need to have the same denominator. So we're going to multiply this 2 by the number 1, but we write the number 1 as x minus 2 over x minus 2. Now, all three terms have the same denominator. And when that occurs, if we multiply every term, both sides of this equation, by that common denominator, we clear all the fractions. We clear the denominators. So on the left-hand side, we have 2, and on the right-hand side, we have x minus 2 times the quantity x minus 2. So we take this negative 2 and distribute it to both terms. It sometimes helps students if you put a 1 as a coefficient in front of any x's like that, just as a visual aid in helping that 1 minus 2x is a negative 1x. If we subtract 4 from each side, and here we see that x has to be 2. Now, it can't be 2 though, because look up here, I should have made the remark that, remember we were talking about division by 0, if x is allowed to equal 2, it would cause that division by 0. There's no way that x equals 2 satisfies this original equation, so we refer to x equals 2 as an extraneous solution. When you multiply both sides of an equation by a variable, you introduce the possibility of adding extra solutions. So the x equals 2 is a solution to this equation, 2 equals x minus 2 times quantity x minus 2. But it's not a solution to the original equation because it causes division by 0. So this is an extraneous solution. And our final answer, since that was the only candidate, that this has no solution, this equation. All right. So let's come over and take a look then at number 5 and try to approach it in the same way. So let's factor any denominators. Here we have x plus 3. And here with 2x plus 6, we see that 2 is the greatest common factor here. So we have 2 over x plus 3. And then we have 1 over x minus 2. So the common denominator that we want in every fraction here is 2 times the quantity x plus 3 times x minus 2. So on the left-hand side, this denominator is missing a factor of 2 and also a factor of x minus 2. On the right-hand side, this first term, this denominator, is missing a factor of x minus 2. So x minus 2 divided by x minus 2, that's just the number 1. So we're not changing the value of any of these terms, but we are going to get a new expression for each term, and all of these terms will have the same denominator. right, so now that every denominator has 2 times the quantity x plus 3 times the quantity x minus 2, we can clear these fractions by multiplying both sides of this equation by that common denominator. So if we do that, we'll have 3 times 2 times x minus 2. Well, 3 times 2 is 6. And here I'll distribute that in just a second. And here I've got 5 times x minus 2. And here I have 2 times x plus 3. Now, let's come up here and make the remark now that this new equation that we have right now, it might have a solution of -3. And if it does, we have to throw it out because -3 causes division by 0 in the original equation. And if this resulting equation here, after we cleared the denominators, after we cleared the fractions, if it provides us a solution of 2, we're going to have to throw it out because it can't satisfy the original equation. Both of those values would cause division by 0. But they could both be solutions to this equation that we have here. So we have one equation and one unknown, and let's solve for x. Let's apply the distributive property here. Let's apply the distributive property here. And let's apply the distributive property here. All right, so now on the right-hand side, we have like terms. We want to combine these like terms. So on the left-hand side, we have 6x minus 2. And on the right-hand side, the 5x plus 2x combined to give us 7x. And -10 plus a +6 is a -4 there. So if I subtract 7x from each side, 6x minus 7x is a -1x. If I add +2 to each side, -4 plus a +2 is -2. And so this is, if I divide both sides by -1, x equals 2. But remember, we said that there's no way that x could equal 2 because it would cause division by 0. So although x equals 2 is a solution to this equation that resulted after we cleared the denominator, it's extraneous with respect to the original solution. So we have another no solution answer. All right, so let's take a look then at this number 6, and I'm sure it's a problem that we can solve in a similar fashion that we've done with 4 and 5. All right. So we look to the denominators, and we want to have these denominators written in factored form. On the right-hand side, we see this denominator is the difference of perfect squares, so it factors to x plus 5 times x minus 5. That's the denominator that we want to see in every fraction. So we come over on the left-hand side, and with this first term, we multiply it by the number 1, but we write the number 1 as x minus 5 over x minus 5. And the same idea in the second term. We're missing a factor of x plus 5. So we multiply this by the number 1, but we write 1 as x plus 5 over x plus 5. On the right-hand side, we have the denominator that we need, so we don't do anything to it. So if we're to multiply both sides of this equation by this common denominator, we've cleared our fractions, and we have 4 times x minus 5 plus 2 times x plus 5, and that's equal to 32. Now, this equation could, however, give us solutions that we call extraneous. We know that we can't have in the solution set a negative 5, and we can't have in the solution set a positive 5, because those two values could not satisfy the original equation. They would result in division by 0, and that's undefined, and you can't add two things that undefined doesn't equal undefined in an equation. So uh, we can't allow those two values in our solution set. So let's solve this equation by distributing here the 4 over the subtraction, and distributing here the 2 over the addition. And now we combine like terms. And you just have to be careful and not make arithmetic errors. Add 10 to each side, and divide each side by the coefficient in front of x, which is 6, and we have that x is equal to 7. That's not one of the values that we were concerned about. So I fully expect if we substitute in x equals 7, that the left-hand side of this equation will equal the right-hand side after you've plugged in that number 7. The technique requires that we check for extraneous solutions, but the only extraneous solutions would occur from division by 0, a negative 5 or a positive 5. If for some reason x equals 7 does not check, it's because I've made an error somewhere. That there is nothing wrong with the technique. So let's see. That's all three. Hope that helps, and I will talk to you later. Bye.